500,000 people are injured each year in alcohol-related accidents. For years, prevention programs have aimed to decrease the occurrence of these incidents. Fatal vision goggles were created to assist in these prevention programs. The goggles work by shifting the visual field of the subject. The degree to which the vision is shifted is categorized as levels of blood alcohol concentration, ranging from less than 0.06 to greater than 0.25. We know that the goggles distort the subject's vision and cause erratic behaviors while performing activities such as walking. But do the goggles really affect equilibrium, or is it solely the dramatic shift in vision that renders the subject unable to walk in a straight line? We hypothesize that, while standing still, the goggles do affect a subject's equilibrium.
The hardware setup for this experiment included connecting a Wii board to LabVIEW VI through a Bluetooth adapter. This VI allows for various data collection, but we were only concerned with the center of pressure data. Subjects were randomly chosen within our lab period. They performed the one-legged stand sobriety test, meaning they had to stand on the Wii board and balance on one leg, keeping their arm straight down, their other leg lifted in the air. Data was recorded for 20 seconds or until they failed, in which case they stepped down 3 or more times to stop from falling. This procedure was conducted for 3 trials, without the goggles, with .08 goggles, and with .25 goggles. This was repeated until we had data for 9 subjects. MATLAB and Minitab were used to analyze the data.
On this image, it can be seen that the center of pressure points for the trials with the fatal vision goggles, the purple and green points, are much more dispersed than the control trial, the blue points, which are more concentrated around the average center of pressure. In MATLAB, the distance between each point and the center of pressure point was calculated and averaged for each trial. This graph depicts the variance in the trials. T-tests were conducted between the control in the .08 group and the control in the .25 group. Both tests yielded significant results, with p-values less than .05.
P-values for increased average variance between the control trials and the trials with goggles were less than .03 for both x and y directions. This shows that both the .08 and .25 BAC goggles significantly impaired balance for the subjects tested. Our hypothesis was thus supported by the data gathered. Another representation of our data clearly shows the deviation in balance resulting from the use of the fatal vision goggles. Although not part of our hypothesis, a correlation between higher simulated blood alcohol content and greater impairment of balance was expected. However, there was no significant difference in average variance between the .08 and .25 trials. This may have been due in part to subjects becoming acclimated with the goggles' effect on balance before trying on the second pair. Fatal vision goggles are used by law enforcement personnel to imitate the effects of alcohol impairment. Because of the inability to test alcohol-impaired subjects, any conclusions must be attributed to the goggles and not necessarily alcohol impairment. Our results for balance impairment agreed with the results expected from our literature search. 2 different articles showed a significant impairment of balance in subjects with alcohol intoxication. Improvements for future studies might include the testing of subjects under actual alcohol intoxication. This could strengthen our conclusions by not having to rely on the simulated intoxication of the goggles. A larger measuring surface would help to eliminate the tendency of subjects to step off of the Wii board when they lost their balance. This could allow for more accurate measurements for the center of pressure. Driving under the influence has become a major problem in the United States. There are over 15,000 deaths a year attributed to DUI. Our goal for this experiment was to simulate and test the effects alcohol has on balance. The results show that wearing the goggles significantly increases the variance in center of pressure, which indicates impaired balance. Paired t-tests comparing control trials with goggle trials resulted in p-values of less than .05, so the null hypothesis was rejected. Our experiment shows that fatal vision goggles cause a statistically significant increase in balance impairment. Although our simulated intoxication supported our hypothesis that the goggles would impair balance, an objective evaluation of the goggles' accuracy in simulating alcohol intoxication would help to draw stronger conclusions about alcohol intoxication's effect on equilibrium.